Welcome to Vision Plus and welcome back to this Senior for Mathematics. We are looking at equation of a tangent to a circle and we are now on example 5. We are going to solve example 5 using two methods. The first method that we shall use is the method of the gradient function. The gradient function of the circle, which is dy dx. And then method 2 will be the method of perpendicular lines. So let me start with part A using method 1. Part A says find the equation of the tangent to the circle. The circle is defined by x squared plus y squared plus 4x minus 2y equals to 0. At the point of tangency is negative 1 and 2. This is the point of tangency, which is the point on the circumference of the circle where the tangent touches the circle. So with method 1, we are going to treat the circle as an implicit function. So we shall differentiate both sides of the equation. So the x of the function on the left hand side, which is x squared plus y squared plus 4x minus 2y equals to d dx of the function on the right hand side, which is 0. Our markers. So we're going to differentiate this function. We will differentiate x squared, we get 2x, which is a function in x, so we say dx. But we are differentiating with respect to x, dx, plus y squared. If we differentiate y squared, we get 2y. It is a function in y, so dy, but with respect to x, dx. And then plus, if we differentiate 4x, we get 4. It is a function in x, so we say dx, but with respect to x, dx, minus, if we differentiate 2y, we get 2. It is a function in y, dy, with respect to x, so dy dx equals to, if we differentiate a constant 0, it gives us 0. So let's simplify simply by cancelling out dx here and there, so that we have 2x plus 2y dy dx plus 4 minus 2 dy dx equals to 0. Now let us make dy dx the subject, because that is the gradient function we are looking for. So I'm going to collect the like terms. I'll have 2y dy dx, which is here, minus 2 dy dx equals to, I'm going to carry 2x and 4 that side. Therefore, it becomes negative 2x minus 4. They become negative on crossing the equal sign. And now let us factorize so that we get dy dx. So that we shall have 2y minus 2 dy dx equals to negative 2x minus 4. Both sides by 2y minus 2. Therefore, dy dx becomes negative 2x minus 4 over 2y minus 2. This is the gradient function of the circle that we are looking for. Gradient function of the circle. What is the meaning of the gradient function of the circle? That is an equation, okay? That is a function that defines for us the gradient of the circle at any point on the circumference of the circle. So if we have the gradient function, and we have the point of tangency, which is on the circle, then we can find the gradient of the circle at this point of tangency. Therefore, at the point of tangency, -1 and 2, we can find the gradient of the circle. Therefore, dy dx at the point of tangency, -1 and 2, we can find the gradient. This is our x, this is our y. We substitute for them there. That gives us there -2. What is x? X is -1 minus 4 out of 2. What is y? Y is 2 minus 2 equals to, let me press the equal sign. Let me press the calculator rather. -2 times -1 minus 4. I'm getting here -2 over 2 times 2 minus 2. I'm getting 2. -2 divided by 2 is -1. So this is the gradient of the circle at the point of tangency. What do we know? We know that at the point of tangency, the gradient of the circle is the same as the gradient of the tangent. Therefore, gradient of the tangent is -1. That is the gradient of the tangent. Knowing the gradient of the tangent and the point of tangency, which is also the point on the tangent, we can find the equation of the tangent. So to find the equation of the tangent, we have the requirements we need. What are the requirements? One is the point of tangency, -1 and 1. And then 2, we have the gradient of the tangent as -1. A tangent is a line. Therefore, equation is given by 1 plus mx plus c, where c is the y-intercept. That is a point on the y-axis where the tangent meets or cuts the y-axis. So substituting this x, this is y. 2 equals to gradient -1 times x, which is also -1, plus c. -1 times -1. Use a calculator. It is +1. If I take that side of the equation, it becomes negative. Therefore, my c is going to be 1. After getting c, which is the y-intercept, then you come and substitute for n and that value of c. So then now the equation becomes y equals to n. What is n? -1x plus c. C is 1. Therefore, y equals to -x plus 1. This is the equation of the tangent to the circle at that given point. So this is method 1 when we are doing part A.